Hi, this is Craig Stocks here at Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today I'm going to be talking about imaging Comet 12P, Pons-Brooks. It's very low in the west, just a little bit north of due west, right after sunset. You can still catch it, but you have to be fairly quick. In fact, the picture that's currently on our home page is a picture I took, I think, last month that showed the comet Pons-Brooks and Andromeda very low in the west beyond our observatory buildings. So this is the image we're going to be producing, and this was data I collected last night for a hourly rental customer, and Don gave me permission to use the data to produce this video. It was very low in the west, and in fact we chased it all the way down to the ground. I think it was around maybe 20 degrees a half hour before astronomical dark, 20 degrees elevation, and we chased it all the way down to when it went behind the hills in the distance. So we'll look at how to process this data in a combination of PixInsight and Photoshop. So we're going to start in PixInsight, and the first thing we need to do is just review the data and see if it's any good. This review or culling is something I always do. Typically with an hourly rental customer, I would pull out any of the bad frames before I send them the data, just because it just gets in the way, and more bad data does not make a better picture. So I'm using the process image inspection blank function, and I'll just click the file open, and we'll navigate to where the comet data is stored, and I'll just select all of these. There's, I don't know, 28, 30, something like that. These were 2-minute subs starting at around 9 o'clock our time, which is let's just look real quick. It started at 9:01 was the first image, and 10:14 was the last one. So we'll just select all these and open these for review in the blink tool. What I like to do is just step through and look at them, and basically I want to clean this folder. I'm going to take out any of the subs that I don't want to use. So what I'll do is scroll through, look at the data, and then I'll move anything that isn't up to par. I'll move it to a rejects folder. So here's the first image, and I'm going to go ahead and click the histogram tool here, which will apply a unique screen stretch to each image. By default, it calculates the screen stretch for the first image and then applies that same stretch to every subsequent image. But this way we'll see each image on its own. And you can see there's a pretty dramatic gradient. The comet was actually probably sticking more or less straight up, and so there's a pretty significant gradient here in the west. So let's just step through. And I'm just using the cursor key to move down, so now we're getting probably closer to astronomical dark, but the comet is still high enough that we're getting a lot of nice fine detail in the tail. And you can see there's also a lot of plane trails. Here's one that there's enough tracking error that it's just not worth keeping. So I'm going to click on the Move Selected File to a new location. And I just keep a rejects folder on my D drive. So I'll select that folder. And it just moved this folder, this file. It still shows in the list, but it's actually been moved out of this folder and into the rejects folder. So now we can just continue scrolling through. And again, if we see anything that looks particularly bad, we'll just select Move. Same way here. And I would say there's a lot of good data. We don't need to include bad data. And I'm looking at a combination of the star trailing as well as just the overall detail. And some of these, if we look at here's the ground, so you can see how low it was getting. So we'll move these two out. That one I don't think is adding much. That one's not adding anything. That one's really not adding anything. And I think those are the last images. So I'll move those over. Now we have nothing but usable data in this folder. So I can close the blink tool. And now we're ready to just go through the normal batch processing with WBPP. So I'll go to Weighted Batch Preprocessor under Scripts. And we'll configure this. Now this was captured with a one-shot color camera, the ASI 6200. So let's start by clearing all of the fields. And we want to grab the lights first. So I'll navigate to the folder that has that Comet data that's been cleaned up. And just select all of those files. So there's 24 frames that we wound up selecting. And then for dark, bias, and flats, I normally just send master calibration files, and I like to just load those as an entire directory. So if you click on directory, we'll navigate to where the calibration masters are stored. I have them in a calibration masters folder, and the Takahashi with one-shot color, that's the combination that's used here. And if we look inside this folder, it just has the calibration masters on it. So click OK, and PixInsight loads all of the calibration files in the appropriate place. So let's come back to the calibration tab. We've got to do a couple settings here. We need to be sure to tell it that these are color filter array flats, which I selected one of the flats, and then I'll apply this to all flat frames, in other words, both rows. And then on the luminosity, we'll also need to let it know that these are color CFA images, and we need to select RGGB as the mosaic pattern. And I like to set a output pedestal of 300, and we'll apply that to all light frames, although there are no other light frames listed here. And then for the registration reference image, it'll be auto, and we'll choose in my swap files folder, we'll choose the Comet Pons-Brooks. And at this point, everything is configured and ready to run. I can just select run. It checks the space, tells me I've got sufficient space, and continue. And that's now off and running. Okay, WBPP is done now. So let's take a look at what we've got. And just for curiosity, if we look at the post-calibration, we can see there's 48 minutes of data here. That's what we wound up keeping from the subs that we reviewed in Blink. So if I just double click on the background, that'll let me open the lights master file. And so we're in the swap files master folder, and here's the stack that it created. So this will show the stars plus the comet, and the comet will be blurred because of motion during that 48 minutes or so. So let's update the screen stretch, and you can see very clearly there's a lot of gradient here, and of course that's not going to cause us a lot of problems, but we will need to deal with it. You can see the comet, but you don't see any real detail in the comet. And if you recall the preview we looked at, there was quite a bit of detail here. So we want to pull out that detail in the comet. But what this does have is stars, and they're still a little bit egg-shaped. So we'll start by running the Blur Exterminator, and I'm going to run it in correct only mode so that we're really just addressing the stars. And this will create nice round stars for us. This takes usually about 30 seconds to run. The Blur Exterminator has finished now, and so now we have nice round stars, like we would expect. Of course, we still have a blurry comet, but this frame ultimately is just going to give us the stars. We'll separate this into the stars and the comet, and this gradient in the sky will actually wind up being replaced by just a blank layer. So to process the stars, we've just run Blur Exterminator correct only mode. My next step would be to run spectrophotometric color calibration. And if you've seen my videos before, you know I have the saved icons over on the right that they're pre-configured. So for instance, this SPCC is configured for the one-shot color camera with those filter settings. And so I can execute that by just dragging it onto the image and dropping, and it will run everything for me. I don't know if I need to do anything about the gradient here. Let's see what it looks like. SPCC has finished, and let's update the screen stretch. We might get more uniform stars because we're going to subtract them from the background. We might be better off to address some of this gradient. Let's try the gradient correction tool. That seemed to work best when I played with it before. At a very large scale and very high smoothness setting. And we'll turn off structure protection, and let's see what this looks like. The goal here is to kind of even out that gradient without making any big changes. Yeah. And we'll have to refresh the screen stretch. It's better. It's certainly not perfect. Let's try adding to that a dynamic background extraction. And so here I've got sample points arrayed around the perimeter. That's probably better. So I'll close these. So let's go ahead and stretch this image, and I just will use the screen transfer function, and we want it linked because we have color calibrated the stars. And I think I want to make the background a little darker here, so I'm going to use the mouse wheel and zoom in a little bit on these sliders. Because the channels are linked, if I grab the top one, it will move all of them. And we'll just darken the background a little bit, more or less ignoring the comet. Just trying to get what I think would be nice looking stars. We'll drag those settings down to the histogram transformation tool, click the square to apply, and then turn off the screen transfer function. There we now have a stretched nonlinear image. We want to extract the stars from that and also clean up any noise that's remaining. So I'm going to run a step that includes both Noise Exterminator and Star Exterminator configured so that Star Exterminator will save the stars. And this will take about 30 seconds. And there is our stars layer. And the last thing I will do is I run a little enhanced stars process container that does two things. It increases the saturation, and it also runs a SCNR green to reduce the green. It doesn't completely remove it, but it greatly reduces it. So those are just two processes that are encapsulated in this process container. And at this point, we're ready to save the stars. So File, Save As, And we'll save this as a 16-bit TIFF. And that's done, so we can just park it down here. And just for curiosity, this is what the blurred comet looks like. We can do better with Comet Alignment. So our next step is going to be to align the comet images, and we'll do this in 2 steps. First, we'll align the comet images using Comet Alignment. Then we'll run Star Exterminator in batch mode. So let's go to All Processes, Comet Alignment, and let's just start over here. We'll add files. And what you want to do is go to the swap files folder for the comet, and we want to use the registered. These are the kind of the last step before integration, and Comet Alignment needs registered files. And because I have run this twice, let's make sure we get just the current ones. So there are I think there were 24 that we wound up using. So it loads those in. And we need to tell it where the comet is in the first one and the last one. And then because these are already registered, the comet will have moved based on the time. So it can use the timestamp to move the comet around. So I just double-clicked on the first line, and you can see that it's asking for a registration point. Let's turn on the auto stretch so we can see what we're doing. And we'll zoom in and just click right in the middle of the comet. So there is the head of the comet in the first file. And now let's go down to the last one. And again, we'll double click to open it. Zoom in to see the head of the comet. And we will click in the center of the head of the comet to identify it. So now the program knows where the comet is in that first and last image. Let's give it a destination. So we'll define an output directory. And this is going to be in the same grouping. I'll just create a new folder and we'll name it Comet Aligned 2. Select that folder, and now it's ready to run. I'll just click the solid circle, and it's off and running, and this will take about, I don't know, 2 or 3 minutes. Well, Comet Alignment has finished now, so we can close this window as well as the 2 preview windows. The next step, we want to remove the stars from each one of those comet aligned images, and we'll do that with Star Exterminator. And Star Exterminator conveniently has a batch mode. We don't need to generate a star image, so we'll just click on this process batch, and we'll get another window asking us where do we want to save the starless files. So we'll select a folder, and this will be in another new folder. So new folder, and this will be Comet Aligned Starless. Select that folder, and then select the input files and execute. So our input files are going to be the Comet Aligned that we just created. That's the files right here under Comet Aligned. And OK. So it's off and running now, and this will take about 30 seconds for each of 24, so 12 or 15 minutes, something like that. While this is running, I want to talk a little bit about the astrophotography masterclass that we're going to be having in here in Southwest Utah in the September-October timeframe. And part of the reason we selected that date and time is because we're going to have what may be a naked eye comet. Right now, Comet C2023A3 is not much to look at. This is an image of it, I don't know, a month or two ago. Not much to see, but it's projected to be very large, possibly even a naked eye comet that'll be visible either late at night or early in the morning in the late September, early October time frames. And there'll be a period where it kind of disappears when it's too close to the sun. So there'll be a period as it's approaching the sun, I believe, is in the evening, and then it'll disappear and then come back in the early morning, or that may be vice versa. But just for comparison, here's a photo of the comet Neowise, which I think was the last naked eye comet in 2020. And it was just absolutely amazing to be able to just look up in the sky and see this comet and the tail. It was just amazing. But the focus of the masterclass workshop is not the comet. That's just kind of an added bonus. What we're really going to be focusing on is astrophotography and night sky photography. We'll spend most of the day focused on post-processing. We have access, myself and Dr. Christian Sase, who's the astronomer in charge for the itelescope.net network of remote telescopes. He and I will be co-teaching the class, and between the two of us we also have access to quite a few remote telescopes, either my own or the iTelescope ones that are situated all over the world. So we'll be able to collect data each night, certainly weather permitting. If we don't collect data during the night, we have a lot of stockpiled data to work from. So we'll provide data to work from in the class. And in the evening, as a little bonus, we have permits to use the Bureau of Land Management's land around the St. George area. So we'll go out in the evening and do some night sky Milky Way photography, and then processing that will also be included in the daytime classes. And I will be teaching my workflow using PixInsight and Photoshop. This is an example from the class last year, where this is basically the unprocessed image that we started with, finishing up with this. And this, I believe, was a one-shot color with a combination of just a simple clear filter and a Optilong L-Enhance. So we'll be going over the PixInsight workflow and also the Photoshop workflow and the kind of the step-by-step instructions that make it easy and accessible. So if you're interested, you can check it out on the Utah Desert Remote website. On the home page, you'll see a link for click here for more information, and that's what I just clicked on to go to the page with the details. So as soon as Star Exterminator is done working its magic on the comet aligned images of the comet, we'll pick it up there. Star Exterminator is complete now, and if we look at the results, let's just grab one here. So we'll go to the Comet Aligned Starless, and let's just pick one at random and see what it looks like. So because of this has a strong color cast, obviously, and because we don't have stars to color calibrate, I'm just going to do an unlinked stretch. So I'm going to unclick this link in the screen transfer function dialog box and update it. And that looks pretty good. You can see there's a lot of detail in this particular sub. So this was a good one. A very strong gradient going from kind of red to blue as the comet was getting lower and lower. This was taken at 9:30, so this was taken just right about astronomical dark, maybe a couple minutes after astronomical dark, which I think was around 9:30 last night. What we want to do, though, is stack or integrate all 24 of these into one image. So to do that, let's close these two windows And we're going to go to Process, All Processes, and Image Integration. So we're done with Star Exterminator. Our next step now is to do the image integration. And to do that, let me reset the form. We need to add files, and what we want to add are the Comet Aligned Starless images. And we'll just open all of those. And I'm going to do a pixel rejection of Windsorized Sigma clipping, just in case there's any oddball stuff that we can still clean up the images a little bit. And there's probably not much point in weighing these because there are no stars to calculate a point spread function. And so with that, I will apply global, and we're off and running, integrating the Comet Aligned Starless images into one single image. Okay, image integration is done. So we now have our two rejection images, which I don't really pay much attention to, and this is the integration. So this will be our comet on a starless background, and we still have, as you would expect, we still have this fairly significant gradient going from bright to dark. But you can see there's quite a bit of detail in here. We want to pull as much of this detail out, and of course that wasn't visible in the earlier image with the stars because the comet was blurred. So by doing the comet alignment, we were then able to stack the comet images and get much better detail in the tail of the comet. So first I want to deal with this gradient, and I've done some iterating with this. I haven't found a good one-click solution. Gradient correction that we used before seems to work well if we set a very high scale and a high smoothness, and I think it works better if we turn off structure protection. And let's try this. And it's a little misleading. When it first finishes, that looks great, but then when I update my screen stretch, a lot of times then it looks worse, like that. Let's try checking the auto convergence. We'll see if that helps. I'm not too worried about gradients and junk that shows up in the area around the comet, because like I say, all that is going to be replaced by blank sky in the finished image, but we like to be as clean as possible in the near vicinity of the comet. And again, let's update the screen stretch. Yeah, that's looking along the run of the comet, that doesn't look too bad at all. I mean, we obviously got a big bright spot over here, but like I say, that's going to go away. Let's see if we also do a little dynamic background extraction with subtract. And because of the artifacts where the images didn't stack well, I need to move some of these sample points in away from the perimeter. I probably should redo this sometime and just move them all in a little bit anyway, because this does happen. And I'm going to just go ahead and add a few more sample points and see what this can do for us. See if this cleans up this stretch a little bit. Update our screen stretch. I think that looks a little better. I guess we have to close this in order to undo. Let's do a quick undo. I think that's a little better. So I'm going to go with this for now. I've got good detail up here in the dim area and good detail obviously in the bright spots. I want to do a little bit of deconvolution sharpening, and we can use Blur Exterminator for this. But there are no stars, so we won't be able to do auto PSF. So we'll just have to pick a value that we think is appropriate, and I'm going to just go somewhere in the middle, and we'll try this and see if it cleans up some of the fine details here in the tail. Okay, Blur Exterminator is done. So now it's time to stretch the image, and I want to actually create two stretched versions of this. A bright one that maintains all of the detail and separation out here, and then a darker one to focus on the area right around the head of the comet. So to do that, I'm just going to create a duplicate of the image here. And we'll open up the screen transfer function and the histogram transformation function. We'll do an auto stretch. And because this is an unlinked stretch, in order to modify it further, I want to make this darker. And to do that, I'm going to go ahead and drag the settings down to the histogram transformation. And you'll notice that I currently have the RGB/K curve selected, and that didn't change. But if I look at the individual blue, green, and red, you'll see that each one of those changed uniquely for the image. So if we go back to the RGB/K, I can use this curve now to modify, kind of like adding a modification or an adjustment on top of the adjustment before we apply it. So to do that, I want to preview, so I'll open a live preview with the open circle. And I'll have to turn off the screen transfer function. And I'll drag the blacks in, and I'm focusing mostly on this area. And I want to keep the core dark enough that we don't have a lot of blown out highlights. And actually, just by itself, that makes a pretty nice looking image. But we've got a lot of detail going on here right around the head of the comet. So we'll apply that. And now let's look at turn off this. So now we'll look at the base image. And again, we'll do a reset and update the screen transfer function. And this one we want to keep fairly bright. But I'm going to do the same technique. I'm going to drag the settings down to the histogram transformation tool, open up a real-time preview, and then I'm going to pull in the blacks a little bit. In what I'm looking at here, I'm trying to create good contrast between the blacks and the tail. So I might even brighten the midpoint a little bit. Just trying to create contrast around these details in the tail. And you're starting to see some, here's a artifact from star removal where it left a square. We'll just have to deal with that in Photoshop. And we've got some other spots that we'll deal with in Photoshop. So let's apply this. And now we have two stretched versions of the comet. We have a bright one and a darker one. And the last thing I want to do is apply noise reduction to this, again using this time Noise Exterminator. And I can just drag that onto the image, and it should clean up some of the artifacts that we get from star removal. It's a little bit like walking noise. When you do star removal on the comet, you still get some residual noise. And we'll do the same thing to the bright image. It won't clean this one up near as well. And you can really see those little artifacts. You can try using a larger overlap in Star Exterminator, and that sometimes helps with those artifacts. But in the end, I think we're just going to have to deal with it in Photoshop. So we've got two nice images ready to go into Photoshop. A lot of detail here in the tail. So let's save these as 16-bit TIFFs. So there's the bright one. Here's the dark one. Again, saving this as a 16-bit TIFF. Okay, at this point we are done in PixInsight and ready to go to Photoshop. So as we always do in Photoshop, we're going to start with File, Scripts, Load Files into Stack. And this is where we choose the files that we want to load to create our document. So we'll navigate to where we save those files, and just to make life simple, I'm going to add the date modified and sort these files in date modified sequence. That way the newest images are right here at the top. And click OK, and you'll see it creates a new document, and it's loading each one of those documents as a layer. So now we have 3 layers. We have the dark version of the Comet, which looks very nice just on its own. There's a few artifacts here and there that we could clean up, but overall it looks really good. We have the brighter version that has more detail out here, but also more noise, so we want to be careful with what we bring in here. And then we have the stars. So let's start with the stars, since these are pretty cut and dried. We'll drop it into a group, change the group name to stars. And I like to add a levels adjustment and a hue saturation adjustment. I will typically darken the stars a little bit, and then I'll boost the saturation even more. And you'll notice when we do that, I don't know how well it comes across in the video, but the red stars start to get a little bit overblown. So I will target the red colors and reduce the saturation of reds. And that gives us a nice balanced, colorful stars without the reds going overboard. And you can, I find I like to boost that saturation quite a bit and really bring out the star color. So the last thing we're going to do is put this into screen blending mode and move it up to the top of the layer stack. And in fact, now we can turn it off. Let's deal with the dark layer next. And again, I'm going to drop it into a group, name it Comet Dark. And there's a couple spots that I want to heal, and I'm just going to use the Remove tool. I can use the bracket keys to make it bigger or smaller. And I'm just going to target some of these areas where there's an obvious something happening. And when I click the check mark, because I have I don't have checked the run after each click. Now you can see there's an option to remove after each stroke, and that's not checked. That lets me put multiple spots on and then execute them all at once. I also am not sampling all layers, so I'm only sampling from this layer. Now, we've still got some junk here in the background, and we've obviously got this gradient over here, the residual, and some artifacts from stacking along the bottom. So I'm going to add, remember I said we were going to replace the sky with a blank layer. Let's go ahead and create that blank layer, and it'll go right on top of the top of everything except the star. So it goes right below that star group. And we'll use the yin-yang looking symbol at the bottom to add a solid color layer. And we want it to be about 191919 RGB, which we can get to very quickly by just typing 131313 into the hexadecimal field. And then we'll put this in lighten blending mode. Now the beauty of light and blending mode is anything that's darker than 131313 will get raised to that level. I should say 191919. Anything brighter, it has no effect on. So if I turn this on and off, you can see there's just a few areas where it's having an effect. And that's usually the way you want it. You want it to just barely have an effect. And now I'll just add a blank layer underneath it. And since there's nothing in this area that we're interested in, and we're just going to put stars on top, I can just grab the brush tool with black as my foreground color, and even at 100% opacity, I can paint in here with black. And if we look at that layer by itself, we've just got a lot of black going on down here. But because we have this layer, anything that's darker than that 191919 gets raised up. So there's nothing darker on this in this image than 191919. I'm going to make my image a little smaller so I'm not as obtrusive in the corner. And if I turn that layer off and on, you'll be able to see the impact it's having. It just smooths out the background. So let's see if we can add some more detail with this bright layer. So I'm going to drag it up above the dark layer, drop it into a group again, and we'll name this Comet Bright. And I'm going to add a levels adjustment layer and see if we can fine-tune the background a little bit. You see that helps quite a bit already. Just trying to bring out the contrast, and I'm really only watching, you know, like in here. I want to be careful I don't go too dark. So I'm probably better off something like that. And now I'm going to answer my phone. Well, I think I'm going to have to be a little bit more finessey in here, and I can also see we've missed some of these spots I wanted to fix. So I'm going to turn off this adjustment layer and grab the remove tool and just clean up some of these spots that are residuals from star removal. And again, I'm mostly worried about it close to the comet. And then I'll click the check mark to apply those. So I'm going to turn this back on. You see it's getting too dark here in the center. So I'm going to bring that back up to about where I'm just starting to lose that. And I'm going to switch to burning and dodging. So to burn and dodge, I'm going to add a blank layer and put it in soft light blending mode. And then grab the brush tool with black as my foreground tool to color to darken. Or if I tap the X key, it'll switch to white to lighten. And I can just switch back and forth with the X key. And I want to be at about 10% opacity. And what I'm going to do is darken some of these areas, especially around the comet, like so. And as we get closer to the head, I'll have to be a little bit more aggressive, perhaps. If I go too far, I can just switch to white and brighten it a little bit. So that looks pretty good all around the comet. We're going to use this blank layer up here where we just painted with black. And I'll go ahead and go to 100% opacity. And remember now, this is above this layer. So I'm just just blacking out all of those areas. And if I go too far, I'll have to erase. Now let's see if we can fine-tune this a little bit. If I darken it a little bit, and we're probably going to need a mask here. So I'm going to add a mask. We're still in the bright comet layer, and we don't really want any of the bright comet around the nucleus. So I'm just going to paint with the black on the mask, and I'm going to paint with 100% opacity and flow. There we go. So now we have, let's turn the mask off. You can see what I've done is, let's go ahead and let some of this through. So that's letting some of that bright comet data through. You start to see the square there, that artifact from star removal. So let's come down to the burning and dodging layer, and I'm just going to very gently brighten, gently, with low opacity. Even that's too much. Let's try 5%. Yeah, 5% works a little better, but even that's a little strong. So there's the comet against a solid black background. We're starting to get really good structure through here. We've got the glow coming off of it. You might want to bring out a little bit more in here. Something like that. This is a very high dynamic range target, which is part of the problem. So let's take this the next step. I'm going to take this whole comet group, the bright and the dark, and I'm going to convert all this into a smart object. And the reason I want to do that is so I can sharpen and add some edge detail to bring out even more of the swirls in the tail. So first, I'm going to add a Smart Sharpen Smart Filter, and this will just add some overall sharpening to that layer. Now we're going to use a high pass filter, and that will add a little bit more local contrast or presence, somewhat like clarity. And I may want to add a mask to this. So I'm going to convert this into a smart object again. But we're going to start nesting smart objects. And now I'm going to go to Filter, Other, High Pass. And it doesn't really matter where it's set right now because we have to change the blending mode. Now to change the blending mode of a smart filter, you need to double click on the little adjustment icon way over to the right of the layer. And you'll get the pop-up window where we can change the blending mode of this smart filter to soft light. Now we can come back to the settings for the high pass filter, and as we make the radius larger or smaller, it will have more or less effect. And that's probably pretty good through the bulk of it, but it's too strong around the nucleus. So I'm going to say OK, and now I'm going to use this mask on the smart filter and paint with black and hide that effect right around the core. Lastly, I want to deal with some of the noise in here. It's not bad, but we can smooth it out because there's really nothing going on. It's just a kind of a big glowing blob. So to do that, I'm going to convert this into a smart object again. And I'm going to do two things. First, I'm going to add a motion blur. That's under Blur, Motion Blur. And we can set the direction so that it's more or less matching the direction of the striations here in the tail of the comet. And we can play with the amount. And what I'm doing is just letting this motion blur smooth out those striations. Now I'm going to target the mask, and you can tell it's targeted by the double outline around it. Control-I will invert the mask, so now we're hiding its effect everywhere, so we're hiding this motion blur. Now I can come back and paint with white and paint that back in just in that region. And lastly, I want to do a similar blur up here. So again, we'll convert this to a smart object. So this is about 4 or 5 smart objects deep now. And now I'm going to do just a plain old Gaussian blur with a fairly large radius. And then hide that and bring it back with the mask. And that just hides all that noise that was going on in there. So the last step then is to turn the stars back on. And there we have a completed image with the some kind of high dynamic range techniques. If we want to add some global adjustments to color and vibrance and so forth, we can come up above the smart object and below this layer where we blacked out the background and add for instance, a color balance and play with the actual color. Maybe take some of the blue out of like that. I don't know if that's correct or incorrect, but it looks a little bit nicer with a little bit of yellow and red going on here and the blue through there. So I'm going to say that's pretty close to a finished image. So at this point, I will just save this, save as, and I'll save this in my 2024 photos as a large document format. So this is for the video. And that's saved with everything intact and ready to be imported into Lightroom and shared. I think the last thing I'm seeing some red I don't like here. So I am going to pull up a hue saturation and probably desaturate those reds. Did that get it? I think that got it. So that's the process for the Comet. I hope you found this useful. If you have any questions, be sure to drop them in the comments and I'll do my best to try to answer them. If you're interested in remote hosting or hourly rentals, you can contact us through our website at utahdesertremote.com. And with that, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.